hot and steamy econ. Love it. Love it. All right. So today we get into perfect competition.
Right.
So we're going to start chapter 12. Chapter 12, 13, and 14 deal with what we call market structures. Market structures. And we're thinking about how firms go about maximizing profits under different circumstances. So first of all, we never want to lose track of the firm's objective, our assumption anyway, which by the way can be relaxed in different circumstances. They are out to maximize, what's their objective? Profits. So maximize profits, which are equal to total revenue minus total cost. So we don't want to lose sight of that. We're going to look at 4 market structures to try to gain some insight about why firms do what they do in order to maximize profit. So these market structures are kind of the environment that the firm operates in. So what do I mean by environment? Well, like, are there other competitors? What type of good do they have? Is it easy to get in and out of the industry? A number of different things. And so what really is going to separate out their environment is the level of competition, ultimately. So we kind of want to key in on the level of competition. And to do that, I like to think of a spectrum of competition. At one end of the spectrum, we have what economists call perfect competition. At the other end of the spectrum, we have no competition. The firm has no competition. What do we call that?
Monopoly.
Monopoly. All right, so a monopoly. So that's what we're really investigating is what would cause firms to be in one place or the other. And so chapter 12 is on perfect competition. We're going to spend the whole chapter talking about the characteristics of perfect competition. Then we're going to spend all of chapter 13 looking at no competition, monopoly. And then we'll investigate the in-betweeners. And really, most of the world operates in between. And one of the in-betweeners is called, one of the hybrids is monopolistic competition, a hybrid of the words. Monopolistic competition. On my spectrum, notice where I drew my hash mark. Closer to competition, closer to perfect competition. So I did that intentionally. Monopolistic competition falls a little closer, so there's a little more emphasis on the competition part, even though it comes second in the titling of it, monopolistic competition. Competition is probably the more important part of that title. All right, and then our other funky one, instead of a monopoly, we're going to have an oligopoly. Probably a new word for a lot of you. Oligopoly. Oligopoly. And for now, we can just think of that being maybe just a few firms. A few firms. So we got, I couldn't remember for sure if this was combined or not, chapter 14, chapter 15. spend a chapter on each one of these market structures. Okay. Today we start off with perfect competition. And what I want to help you define it by right off the bat is the characteristics. There's these defining characteristics of all four of these market structures. So perfect competition characteristics are, one, we're going to have a large number of sellers. A large number of sellers. What do you mean by large? I mean so large that each one is basically insignificant to the overall market. So if I take this bucket and I fill it up to here with water, and I take an eyedropper and I put one drop of water into the bucket, are you going to see the bucket level rise? No. That's what I mean by a large number of sellers. Every individual seller is so small relative to the overall market that they're kind of insignificant in a sense to it. And that has some important implications. So a large number of sellers, each one is a drop of water in the bucket. Each one's a drop of water in the bucket.
So things like brand names are less significant in such a market, so to speak.
Let me just pause on that.
Okay.
Before we get that close. We'll come back. That one can start to muddy the water too quickly. We will muddy it.
All right.
But it's a little too early to muddy it yet. So, number two, we have a homogeneous good. A homogeneous good. What do you think that means? So the good that we're talking about is homogeneous among the sellers.
Similar, almost exactly.
Similar, almost exactly, basically exactly, identical products is how you want to think about that. So basically the same good. So virtually identical products. Now, let's tie that back to our Chapter 3/Chapter 4 concepts of substitutes. If two goods are virtually identical with each other between two sellers, how would you say they're related? Are they substitutes or complements? What type of substitutes? Perfect substitutes, right? Almost like perfect substitutes. It's like, I don't care. Give me one or the other that are basically the same thing. So the consumer is really indifferent between those two sellers' goods. So virtually identical products causing them to be perfect substitutes. That's an important feature of perfect competition. And number three, we have free entry and exit. Free entry and exit. We talked about profits being a signal. If the English professor was making lots of money, what was the signal going out to the market?
It's okay to be an English professor.
Ah, no.
If he was making lots of money.
Enter the market, right? So that was the signal that was going out, was to enter. So other entrepreneurs are like buzzing around, looking to do what? Maximize profits. They see an English professor who's making a bundle of money far beyond his or her opportunity cost, And they're like, oh, I'm going to flock to that industry. I knock on the door. Can I get in? Yes, because it's easy to get in. Free entry and exit. So free entry and exit is kind of easy to enter and leave the industry. Okay, I don't hear lawnmowers, so you guys want to open back up? Oh yeah, the lawn looks nice and slowed. You guys want to open?
Yes.
It's easier to open than to close, so I got an easier job. Now I see why they had them. All right, there's a little fresh air. I might start breaking into a sweat. All right, so does this look pretty ridiculous to you? Do you guys know industries that look like this? Cell phone industry, McDonald's, Corbin brought up generic brand goods or something. Does that fit all of these criteria? Is there anything that fits that criteria? Is there anything that comes close to fitting maybe that criteria? So virtually identical products, whole bunch of sellers, and pretty easy to start up or get out.
When we're talking
Think about breakfast. Sorry, Mel. Go ahead.
Sorry. I said, whenever we're talking about entry and exit, are we talking about the industry? Or are we talking about the...
We're talking
employee?
about an individual company's ability to start up the business or to quit the business, to get in or out. Kind of easy to get in or out.
So like,
So think about breakfast. Maybe what you had for breakfast. What did you have for breakfast?
Eggs.
Eggs. Caleb? Nothing. No breakfast. Man after my own heart. Michael? Pop-Tart? Dallas? Cereal. What'd you put in your cereal? What'd you put in your cereal? Milk. Okay, so we got eggs, we got milk. Those kind of jumped out. How do you think those fit in here?
I guess you could milk can be easily substituted for any brand.
Okay, so does milk fit this category? Let's stick with milk for a second.
Yeah.
Yeah, in fact, if you look on the label close enough, I think it tells you this, right?
Yeah.
It's homogenized milk, so it's all pretty darn close to each other. So virtually identical. Are there a large number of milk producers?
Yeah.
Yeah, they're all over. There's dairy farms all over the place. Easy to start up a milk business, buy a cow, start milking it, sell it. There's probably some machinery and stuff, but maybe you could rent some tanks from somebody. You know, it's not too hard to get in. So, agricultural products, eggs, milk, meat, corn, all kinds of egg products. Pork butt, I like cooking pork butt. Bacon, you know, meat, beef, all of that kind of fits this category. So, ag products are kind of our primary example that comes close. So ag markets are probably the best example. Eggs, milk, wheat, corn, soybeans, the list goes on and on. Now, you know, just to play off of that again, to kind of illustrate how this is really an extreme, somewhat theoretical endpoint. You know, even milk has a little bit different label. Milk does a body good. Maybe there's some advertising that influences us with Robert's Dairy versus Great Value brand or something like that, right? So there might be some other things, or maybe organic, and we could put all organics into a class. You know, we can start to play games with it a little bit, but for the most part, it gives us a pretty good example of that. All right, so that's our perfect competition. So what are the implications of that? So to model that, let's draw our Chapter 3 home base. So we're going to start off by, where's my black marker? Let's start off with 2 two graphs side by side. On the graph to the left is home base that we did in chapter 3. Downward sloping demand curve, upward sloping supply curve, some sort of initial starting place, P1 and Q1. We've got big Q, we've got price. And maybe this is the corn market. So we're looking at the corn industry. Over to the right, I'm going to draw the representative firm, Farmer Joe. So here's Farmer Joe. And we're going to call him the representative firm. He's one firm, one drop of water out of the bucket. Right? So we're just saying, well, suppose we got the average seller listed over here, Farmer Joe. Now I want to think about how his behavior is in this environment. Right? So that's what this whole thing about was thinking about the different environments that we have. And so if the price of corn is going for $5 a bushel, tell me about Farmer Joe's situation.
He has to accept $5 a bushel.
Okay, he's got to accept $5 a bushel, right? So he's kind of powerless. He's a drop of water in the bucket. What the market tells him is what he kind of gets. We call him a price taker. He's a price taker. And so if Farmer Joe kicks off 100 bushels, he gets $5. If he does 200 bushels, he gets $5 a bushel. If he does 300 bushels, he gets $5. $5, $5, $5, $5, $5, $5, $5, $5, $5. If we start mapping out all potential quantities that he can produce, we can show a relationship between the quantities he's producing and how much people will buy for his corn. And that maps out the demand for Farmer Joe's corn. Perfectly elastic. Good. So a perfectly elastic demand curve for Farmer Joe. All right. So our objective is to maximize profit. What does Farmer Joe need to take into consideration as he goes about that? Should he produce 100 acres, 200 or 100 bushels, 200 bushels, 300 bushels? I mean, what is his optimal quantity? You know, what is the optimal profit maxing quantity for Farmer Joe? I'm going to put a little Q, I didn't do this yet, put a little Q here for Farmer Joe. So we got big Q for the market, little Q for Farmer Joe. So what does Farmer Joe need to take into account?
That it's not just his corn they're buying.
Okay. What else?
His cost.
His costs. Right. So we need something with costs. All we have here is revenue. Revenue is equal to what? Equation goggle, people? Price times quantity. All right. So now we've got some total revenue numbers here, right? So if he we could do like an if-then analysis. If he produces 100, how much revenue does he have? 500, right? So $5 times 100. We could do the little area of the rectangle. This little rectangular area would represent the total revenue associated with producing 100 bushels. If he produced 200 bushels, he'd have how much revenue? 1,000. 200 is the base of this rectangle. The height is 5. We could fill that in and say his total revenue is that rectangle. I see a couple people grimacing because we're back to geometry again in this class, right? So we've got $200 or $1,000 worth of revenue. All right, but that's only one half of the equation. What did we learn from last chapter about what happens to the cost of additional bushels of corn? They go up. The law of diminishing marginal product drives the law of increasing cost at the margin. So the marginal cost curve is J-shaped and upward sloping. So let's just draw a little J in here for fun. Let's just say it goes, his situation looks like this. Bottoms out at 100, comes up through that 200. You guys are kind of mapping out the way I did it here. What quantity should maximize profits?
Oh. Is it 200?
200.
Would it be 100?
100. Does anybody want to go 300?
No.
300 doesn't look good, right? We've
300
got
look
cost here, demand here. We've got 100 and 200. All right, so 100's got this nice big distance here. 200's got no distance. Aren't we trying to maximize profits?
Yeah.
So you're changing to 200 now? Or 100? You said 100.
I said 100.
So you were right. Okay, sorry, I need my 200 people.
Sticking to the guns.
All right, well, I got a little thought exercise for you. Suppose we are here. And let's just say that the cost, marginal cost associated with that quantity is, what are we at here? About a 2? Okay, just kind of using round numbers. Remember, this kind of came across the page. This is 5. So here's Farmer Joe kicking back after a hard day's work, and he's thinking, would it be wise to kick out 101 bushels instead of 100 bushels? That's the decision we want to think about. Would it be a good idea to increase production by just 1 lousy bushel? What do you think? Three, where'd you get the 3?
Yeah, 101 times.
So I want to think about 101. I'm just going to do not quite to scale here, but imagine 101 is here. So should we change from this to this? Because if we're at the optimal, then the answer should be no, right? I mean, if that's the good place to stop, then we shouldn't go further. So, Chance, good stretch for you back there. What do you think? Should he do the 101st bushel? Should he increase by 1 extra bushel?
No.
No. Any reason why, or just taking a stab?
Just taking a stab.
How much could he sell that 101st bushel for?
$5.
Hold on. How much could he sell that 101st bushel for? Go back to the market. What's the equilibrium price in the market? 5. Does he have any power on the market? How? He's a drop of water in the bucket. So it doesn't matter what he produces. If he squeezes out another drop, we don't see the water level rise. So he is insignificant to the overall market, which means he's going to take whatever the market says. So he calls up his stockbroker on the Chicago Board of Trade and says, what's corn going for? He says $5. He said, okay, I guess I can't do anything about that. I'm going to take the price that's given to me. So for the 101st bushel, he's going to get $5. What's it cost him? 2 and 1 cent or something. How'd you get that, Caleb?
It's just a tad bit up from the middle.
All right, Chance, did you hear that? You kind of tapping out on me or what?
No.
What's the cost of the 101st bushel? Caleb, what's the cost of the 101st bushel?
$2.
$2 and a little bit, right? Chance, what's the cost of the 101st bushel? $2 and some. What can he sell it for? $5. How much could he possibly make? $2 something. Is that worth doing?
Yes!
Yes.
Money!
Right? Do it. Do it. Do it.
Yes!
Do it. So the 101st bushel brings in profit of $3. What about the 102nd bushel? Now time out here. Lewis, 102nd bushel. How much is he going to sell that 102nd bushel for? $5. What does it cost him? A little over $2 in somewhere. How much is he going to make on it, roughly? $2.70, $2 something. Should he do it?
Yes!
Yes, everybody!
Yes!
Yes! Yes! Yes! Yes! When should he stop?
At 200!
When should he stop?
At 200.
At 200, because the 200th
Stop making money.
costs $5 to make, and he brings in $5. So stop there.
There.
We've just uncovered the holy grail of business. How does a firm maximize profits? By producing the quantity where the revenue generated by the last unit produced is just equal to the cost of the last unit. In other words, no matter where you're at in production, if you're down here, you're above here, think at the margin. What if I cut back? Let's go to this absurd 300 that you guys didn't go for. The cost of the 300th unit was $10, and I was only bringing in $5. Whoops, maybe I went too far. Should I go even further? No, that would be stupid. Let's go backwards. And then I find out that the 299th bushel cost me $9.98, and I'm only bringing in $5. Is that a good unit to produce? No. So keep going until
Hit 200.
you get back to 200. So no matter where you're at, by using your head, you can maximize profits by taking baby steps. It's always like, should I do this? Should I not do this? Evaluate the marginal benefits and the marginal cost. In this context, the marginal benefit is the revenue generated by an additional bushel. So what is the marginal revenue? I'm switching on you a little bit. What is the revenue generated by the 101st unit? $5. What's the revenue generated by the 200th unit? The revenue generated by the 300th unit? $5. The revenue generated by each additional unit is the market price. Under these circumstances, since he's a price taker. So the demand curve and what we're now going to call the marginal revenue curve lie right on top of each other.
Easy graphing.
The profit maximizing condition that we want to focus in on is equalizing the marginal revenue with the marginal cost. So what is the optimal profit maximizing quantity? Down here, the answer to that is a quantity, little q, equal to 200, because that is where the revenue generated by the last unit produced is equal to the cost of the last unit. MR equals MC. And we've squeezed out every profitable opportunity. That is the best we can do.
Did you actually write cuz?
Yes, that's my shorthand.
Okay.
Before texting was, and this is legit, this is on the books somewhere. I think there's some students at Iowa State. Before text messaging was invented, maybe you guys don't use this, I don't even know, but I invented cuz. So if you use that, that was my shorthand. So yes, quantity equals 200 because, and we could put a little star above this, that is the optimal quantity. Marginal revenue equals marginal cost. Next question, how much money is he making?
How much is he making?
How much money is he making?
Hang on.
Okay, so got a don't know because we don't have total cost.
You have to.
Anybody want to challenge that?
We have to find the area between cost. Wait, no, total cost. Okay, let me think here. Hang on. I got this.
So we need total cost. This was, what would you call this blue line I got right here? So more specifically, what would you call this blue vertical distance? Profit, more detail though.
On that bushel.
On that bushel. That's the most important part. It's on that bushel is that amount. So we can't get the answer by taking the area of all of these because you guys get
Oh,
pull out a piece of paper, blank piece of paper.
oh.
Put your name, put Russ Busted, put today's date, which is the 16th,
I'm happy I wasn't.
and pass them up here. You got 15 seconds for all the papers to get to me. 1,
Oh my god.
2, 3, 4,
Does the date need to be on?
10, 16, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, just in time. All right. Those. All right. So,
That was 1 point.
Because it's exciting.
before I was so rudely interrupted, let me make sure I shut my phone off so we don't give you guys another point. I know you wouldn't like that. All right.
It's okay, leave it on.
The reason we can't take that area is because of fixed costs. Long story short, it's because of fixed costs. So if you had a whole bunch of fixed costs, the cost of the first unit doesn't include that part, right? It doesn't change. So the profit calculation has variable cost and fixed costs. What we've kind of captured here for each additional unit is the profit compared to the variable cost. But that's not the whole picture. So as was correctly pointed out here, we need total cost, and furthermore, we do not have that information on here. What would be a helpful curve from Chapter 11 to add to this graph? The average, which one? Fixed cost?
Fixed cost. No.
There'd be an easier one than that. I don't think that would give you average total cost. That would be even better. All right. Now, what does that average total cost curve look like, the general one we've been using? Is it upward sloping? Is it it's a big bowl, right? It's that bowl-shaped one. And so if that bowl looks like this up here, remember it's got to cut through the minimum point. We always got to obey those rules. If the average total cost looks like that, how much are profits? Now you've got that information. What's that, Caleb? There's none. So profits are 0?
You're suffering a loss.
They're actually negative, right? They're worse than 0. They're negative. They're a loss. All right, so back to our profit equation, total revenue minus total cost. We can recharacterize that. So what are the profits? Or what is the profit? Probably be a little bit better. What is the profit for the firm at Q star equal to 200, our profit maximizing quantity? Well, we get profits are equal to, we did that price times quantity and average total cost. Do you remember this little trick? You can take the average cost per unit, multiply times the quantity. I slipped that one in once or twice on you before. Now it kind of comes in handy to think about profits that way, because we can say profits are equal to the price per unit minus the average total cost per unit times the number of units that we produce. In this case, we get $5 minus some number. How do we find that number? If this is the information that's given to you on the homework or test, what's conceptually what you do to learn what the average cost per unit when I produce 200 units is? What do you do graphically, visually? What's the process that you go through?
Average variable cost plus average.
Nope, we don't need, we can use just the average total cost curve. We've got enough information on the graph right now. Not quite enough to plug in a number, but I want you to conceptually tell me, because this is where students struggle with, how do I use the graph?
It's greater than 5.
Straight up from 200.
All right, straight up from 200, good. So I'm producing 200 units. What's the average total cost of producing 200 units? Well, this information's provided up here. I go up to the average total cost curve, hang a left, and read off that number. That is the average total cost of producing 200 units. Just making up a number here, let's say it's $7. So $5 minus $7 is a $2 loss per unit on how many units?
200.
200, giving me a loss of $400. Wait a second, I thought we did the Holy Grail. Remember Russ, you said this is so awesome, this is how businesses make money. Obviously the Grail was a fake or something. What's true if we produce 195 units to that loss? What's going to happen to that loss? It's going to go, yeah, kind of a tricky one with the negative. Is it a bigger loss or a smaller loss? Smaller loss? Let's go the other direction. How about at 205? If I ramp up production to 205, what's going to happen to that loss? Is it going to get bigger or smaller? It's going to get bigger, right? Because we're adding on units that cost more than the revenue generated by them. So we're losing more on each additional unit. Now, if I back off to 195, I can kind of go put it back in forward gear and say, should I do the 196th unit? What's the cost of the 196th unit?
Like 5 figures.
Like less than 5 or greater than 5?
It's greater than
Greater than 5.
Greater than 5. The cost of the 196th unit.
Less than 5.
Oh.
Less than 5. You guys already fell apart on me, right? So the average cost is something up here, $7.10. But what's the cost of the 196th unit? Which curve do I use? The marginal cost curve. The cost of the 196th unit is $3.20. Should I produce the 126th or the 196th unit? Yes, because it's costing me $3.20. Didn't we go through this exercise? I think I'm having deja vu. The 196th unit, I sell for $5. It only cost me $3.20. Should I do it? Yes. What's going to happen to the loss that I'm currently incurring if I produce the 196th unit? Is it going to get bigger or smaller? Smaller. Right? So I'm losing some amount of money. Do you want to lose less money or more money? Less money, right?
Good.
So here's the thing that kind of is cool about this is that the profit maximizing quantity turns out also to be the loss minimizing quantity. So even if you're incurring a loss, you're still doing the best you can by producing the quantity where the revenue generated by the last unit is equal to the cost of the last unit. You will always be moving in the right direction with your business if along the way, each step you take, you think about the expected revenues, the expected cost of that particular action. Even if you're losing your tail right now, how do you make your next move? You got to keep moving forward. What's the best thing to do? Look at the marginal revenue and the marginal cost. Yes, at the end of the day, we're still losing money, but we're losing the least amount of money possible by producing 200. Anything off of 200 makes you lose more. That's why it's the holy grail of business. It works in loss situations, it works in profit situations. You're always optimizing, finding the best quantity to produce. All right. Questions or comments so far on that? We better summarize. Yeah, we better summarize. Now, there's lots of pretty pictures in the material, so you guys will get cleaner pictures and nice stuff. So let's write out that profit maximizing condition. So, quote unquote, the holy grail of business. To maximize profit, a firm should produce the quantity where the revenue generated by the last unit produced is just equal to the cost of that last unit. So, in short, we've already kind of wrote this out, produce quantity where marginal revenue equals marginal cost. And maybe even greater insight is to think about what you do if they're not equal. So maybe a couple extra notes. This is something I don't know if I've ever done before in my 20 years. That's why I love teaching. I just kind of come up with different stuff, kind of wing it. And I learn as I go too. So if marginal revenue is greater than marginal cost, increase or decrease quantity? Increase. If the marginal revenue is less than marginal cost, then we decrease. All right, now, large number of sellers, drop of water in the bucket. Homogeneous good, check. Free entry and exit. What does that do in this particular setting? What's the signal?
You bought the farm.
What's the signal going out to the representative firm? Get out.
Suck.
You suck. Right? You suck. You suck. Oh, the market's speaking to me. Maybe I should go do something else. My highest valued alternative looks awfully nice right about now as I'm sucking air in the corn industry. So I'm going to exit. Now this is the representative firm. So not only is Farmer Joe thinking that, but all the other drops of water are thinking that. If they're all thinking that, is that going to have an impact on the market? Yes. What's going to happen?
Lots of people who sell corn are going to go away.
What's going to happen when they go away? Supply starts to shift to the left. Got to know those chapter 3 demand and supply shifters. Number of suppliers was one of the things that shift the supply curve. As the number of suppliers goes down, price goes up. Those farmers that are able to hang on tight and still stay in business what happens to their loss just from the behavior of others? What happens to the representative firm's losses? They decrease, right? So as this is going up, price is going up, price is going up, making that box shrink. So as supply goes down, price goes up. When is the entry or the exit going to stop? When are firms going to quit leaving?
When the price is
When the price is right.
When they start making profit. What kind of profit? We had a couple of different kinds of profit from chapter 10. Accounting profit, economic profit. Normal profit was another concept. A normal profit, right? So economic profit is equal to what constitutes a normal profit? What is economic profit equal to when a firm's earning a normal profit? Zippo. The signal going out is
You're okay.
you're okay. You're okay. You're not great. You could be maybe doing better. You hope to do better. But you're covering your opportunity costs. There are no better options elsewhere. You're earning a normal profit, a fair rate of return for the resources that you're devoting towards this activity, right? So profits can be fair, and that's the mechanism through competition, entry and exit, that brings us to a fair level of profit in a particular industry, whatever that fair part is. All right, we'll pick up there next time.